Hello everyone, welcome to another data analytica video. So in today's video, we'll have part 2 of PySpark Data Transformation. And here I am on the workbook that we created last time for part 1. So in today's session, in the meantime, let me run all. We will actually have part 2 with window functions, pivoting and melting or unpivoting, then missing data handling, sorting, deduplication and sampling, exploding arrays and nested JSON, user-defined functions and optimization and execution plans, writing data, and then we will have a short summary of what we discussed. Okay, so let's begin with window functions. So I'm sure window functions are already quite familiar. Okay, it's just started. Okay, so in the meantime, let's go to the code. And here we will, there are actually lots of window functions available like in SQL, and in today's video, so I'll be going through the most common like rank, dense rank, lag, cumulative. So these are the window functions that we will actually go through today. And if you are not already familiar with rank and dense rank, so let me just give you an example. So when it's rank, then when there is a tie, so let's say when there is a tie, rank is 1 1. I mean, when let's say like the topmost value are being actually like on a tie, then two records will get 1 1, and the next record, which is on actually the next sorting order, will get 3 instead of 2, because 2 is skipped because of the tie. But dense rank will be 1 1 2. So this is actually the difference between rank and dense rank. And rank and dense rank, they're actually used, both of these are used on different situations depending on use cases. But both of these functions are very common. Okay. Okay, so now let's see rank for because because we are already doing more than one window functions, we'll actually go through more than one window functions. It's actually easier for us to specify the window spec window before, because so that we can actually reuse the same easily. So how to do that? We will actually, what we're going to do is we will do the partition over region, and then we will order by call of sales, and we will order it by descending. Okay, so we will have the partition on region level, and we will look at column sales, and we'll order it by descending level. So let's define now. Let's do use those window functions. df dot with column, and the first thing is rank dot over window spec, so that we don't have to okay, window spec. Okay. Now the next column that we'll have is dense rank, and dense rank of windows dot over window spec. And then lag sales. So if you're not familiar with lag actually sees the previous value when it's already ordered. So lag sales is going to be lag of sales, and to specify, and over window spec. Then the last thing that we're going to see is cumulative sum, and cumulative sum is going to be sum of sales over window spec. Okay. Okay, so we have actually now we have gone through all those 4 window functions that we have already written, and now I will use df window dot show to get the results. Okay, so here we have till year we have the data frame, and then we added 4 more new columns, and here you can see rank and dense rank. They're having same values because we don't have any tie on a region level here, because we get distinct or different values. So because of that, you are able to see we have the same, or the rank and dense rank, we're not able to find any particular difference. And then we have lag sales. So lag sales, if you look at the first value for a region, then its lag sales is going to be null because we don't have any previous occurrence, and under that specific window or the region. And then when it's null, so the second value will take the previous occurrence, that is 300 for that region. And the same logic applies to other regions as well. And then cumulative sum, if you look at the east region, then we have 300 in 300 and null value, and cumulative sum will have 300 and then null, because it's a 0 value it will assume. So 300 plus 0, so 300. And then for the north, 500 and 100, so 500 plus 100, so the second value is going to be 600. Similarly for south and west. So that's it actually, and I would say it's pretty similar to how it's being done in SQL or Pandas or other languages, window functions. So the logic is is actually like quite the same, so I don't think there is anything much to explain. So let's move on to the next data transformation step, or functions that we're going to see. It's actually pivoting and melting. Okay, so for the pivoting, let's do on category level. Let's pivot regions based on sum of sales. So the pivot df data frame is going to be df dot group by, and then category, region. So we'll pivot on region, and then we will have we'll take this value, that is sum of sales, okay, and let's pivot df dot show. Let's try to see. Okay, so here if you look at this, we actually, what we did on when we do the pivoting, we actually transform, let's say, column values into different separate columns. So this east, north, south, west were actually values under the region column before, and after pivoting you can actually see that they actually now they're separated into specific columns, and on each column, like for each category, it assumes the value of sum of sales, and now it's actually like it will show for each specific combinations. Let's say like for East A, we didn't have any value for that, so it will assume null, and then for South A, it assumes null, so all the combinations, it will be shown there. So this is about pivoting. And now if we do the melting or unpivoting, here it gets a little bit I would say the syntax or the expression is a little bit longer, because we need to specify the values that will actually go under a column. Like we need to get it back in a way, like we need to actually use this column headers or the column names as values of another column when we do the melting. So how to do that? We will actually use the pivot df dot, then we will use this function select expression, and we'll have category, we'll use that. At the same time, we will have another column, that is region, with values. So we'll have a key value pairing here. So east, then west, north, and south. As region, and then total sales. And then we will show this melted df dot show. Okay, so here if we look at the difference, then with pivoting and unpivoting or the melting, so this actually, like all the column, different column names, or they're actually now, it's not so it's a kind of like pivoting. When you do pivoting, it's more wider, it's more wide, and when you do the melting or unpivoting, it's actually kind of a long form than the wide form. So yeah, that's what happens. Now we have like all the different columns, that is column values, column names under this region, and we actually use all the combinations from that pivot df, and we take the value, the sales value, as total sales into a different separate column. So that's what we have done using stack and select expression here. So this is how you can actually do the unpivoting in PySpark. Okay, so the next thing that we are going to say is missing data handling. So we know that this is actually a very common problem when we actually get when we do the real case scenarios, where we can have lots of missing data. It can be either null, NA, so unknown, so it can be there can be multiple such cases. So how to handle that? It's very similar how you do it in pandas or some other languages. It's like actually you can have we use here df.na, so handling the not available values, and we mainly used two functions, drop and fill. So when you use drop is it's a case where we don't need those type of values. So what we are doing is actually we will get rid of those rows when it's null. So how you do that? You actually df.na.drop and subset. So the subset, or actually the column that you will check, is sales, and then you will see if there are any not NA values, and if there are any, then please drop that row entirely. So that's what we're going to do here in the using the df.na.drop. So if we look at the data frame, we actually can see that there was a occurrence, or out of this 7, so one of them having sales as null. So let's see what happens when we do this df.na.drop. So here instead of 7 we get 6, because it drops that specific row where the sales value was null. Okay, and then the next thing that we can actually see is df.na fill. So fill is another case where you, in that case, you don't want to drop that specific row where the value is null, but instead of that, what we are going to do is we will actually fill some values when that NA value occurs. So that's what sales will take 0 as value when it's null, and then region, when there is a null value in region, then it will assume the value unknown. Okay, so dot show. Okay, and here if you look at the sales, so we now have seven rows with one row having 0, because that null value gets replaced or filled with 0 here. So that's what happens when you use, say, fill, and you specify the column and how to actually fill those null values, what kind of values you need to use, whether it's 0 or in case of region it's unknown. So region, here we have all values and we don't have any null values, so I'm not able to show you the specific case, but yeah, that's how it's done. So that's it with missing data. We have seen drop or fill, and df.na.drop or df.na.fill. Okay, so we will see the next thing, that sorting, deduplication, and sampling. So these are actually some of the operations that were done on data transformations. And sorting, like, it's very important, or it's very helpful to see the range, like where it starts and what kind of values, or sometimes we need to do small operations after sorting. And for sorting, it's very common, or it's actually like more popular thing is actually to use order by. So order by, and here column sales, and then descending, and we'll show that. So just order by, and then you specify the column that you would like to order and specify whether it needs to be ascending or descending. And then they will see deduplication. So deduplication is actually when you need to have only unique values under a column. So in this case, this deduplicates or drop duplicates is actually the function name. It's very useful. So how to use that? Drop duplicates. and here region. Okay, so we know that in under the region column we have actually like more than one occurrence for, let's say, north, south, and east. So when you use drop duplicates, what's going to happen is these additional or the we actually can see only 4 rows. That means like because there are only 4 unique values. So it will actually drop all other rows which which actually has the same value as before. I'm going to run this and I'm going to show you. Before that, let me write for sampling as well. So sampling is very useful when you have a very large data set and you would like to see the value or you would like to see how the data looks like. So here we use df.sample, and then with replacement is f so here I'm setting false, so that means actually the value can recur or not, because we don't want to see, let's say like because I have set it to false, it will actually get only those rows with no such recurrence. And then fraction we can specify, so I'm going to specify 0.5. 0.5 is like closer to 50% of the data will be actually taken as a sample. And then seed equal to 1, because seed is actually like how many times you have produced the sample. It actually, that seed is different, and you, if you would like to see that specific sample again, you can use the seed number. Okay, so we have all the results. So let's say like, so for sorting, we know that let's sort, if we have sorted it by sales in descending order. So if you look at the 600, 500, 400, 300, 200, 100, which is actually right. And the next thing that I mentioned, or what I showed, was to drop duplicates from region, and here we can see only those 4 rows, because other rows having same, or I mean like the recurrent value of these 4 values, so it will just drop those rows. And the third thing was sampling. Sampling, actually here you can see that we have because we have total 7 rows and up to 50% like 3 or 4, so we have 4 rows here, and it shows so it shows distinct or the unique values, and then we can actually see like what kind of values we have, and yeah, so it will just randomly pick that sample. Yeah. Okay, so that's it about sorting, deduplication, and sampling, which are actually useful functions when you would like to see or actually like order or sort or get the unique values or get a sample on the data set. And the next thing, next thing that we're going to check is explode arrays. Or nested JSON. Okay, so we know that JSON can be having nested values, and if you would like to actually get those nested values into separate rows under a column, or let's say like having an array of values and then trying to explode that into separate column values, so here is the function that we need to use. So let's say like I have a data JSON. So list of values, let's say A is, let's say, category having different products called P1, P2, P3. Similarly, I'll just copy. let's say I have B and then C, and there is P2 and P4, and then C having P1. Okay, so let me create a data frame from this specific data. So create data frame and data JSON, and I will actually specify the schema, so category and products. Now what we need to do is we need to actually do the explode. So for that we will use df underscore JSON dot with column. And when these are actually exploded into separate column values, these are going to have a product value. So product is going to be the name of that, and then explode and products. Show. Okay, so here we are, and we have category A with values P1, P2, P3, and then under product, it's now actually for A, we can see there are actually 3 separate rows having values P1, P2, P3, and then B is another category with actually 2 values in that their array P2, P4. Now they are actually separated into 2 different rows, and then C having value of the product value P1. Okay, and then we have, so that's it about exploding. So exploding arrays or a nested JSON. So what we need to do is we need to actually use this explode function. And then we have user-defined functions. So under user-defined functions, let's say like we would like to have, what we are going to do is we need to have a UDF that will return hi. So for a column, or okay, let's say like for it will return hi if sales greater than 300, else low. No. Okay, so that's what we're going to do. And let's say def, so we will actually specify a function categorize sales, and we'll use the value of sales, and then here we'll return hi if sales and sales greater than 300, else it's going to be low. Okay, so there is actually value for sales, and sales value is greater than 300, then it's gonna get a high, otherwise it will actually take the low as value. So now the next step is to convert or create a user-defined functions using this categorized sales, and the return value we need to specify because it's going to be of string type. So I'm actually specifying string type okay, for the second value, and then I will write with column. So what does it do is actually it will just categorize sales. So the name of the column is sales category, and then what it will do is UDF sales, and then it will take column sales value. Okay. Okay, so here we are with sales category, and sales category, if you look at this till the time it's 300, we have low, and then after that it actually takes value high, and then when it's null it will take the low value as not low. So that's what this user defined functions does. function instead of functions. So function does it actually it can be useful in various cases, and this is just an example of it. So user defined functions like in pandas, they're actually it can be quite handy when it comes to different situations where you need to have lots of conditions and where you need to specify a separate function for it. But at the same time, it's also important to take into account that UDF can be slower, actually usually slower than native PySpark functions. So it's always better to actually use, if performance matters, better to use the native Spark SQL functions instead of UDFs. So in the above case, how we can actually use Spark SQL functions instead of a UDF, I can show you. So what we're going to do is we will actually df dot with column specify sales category, and then when call of sales greater than 300, then so it can be done using when, otherwise, all those different functions which are actually which will help us to specify different conditions. So in the above case, that can be actually used. So here, if you look at this, when column sales value is greater than 300, then it takes the value high, otherwise low, and then show. Okay, so we get the same values as before, but here it's then we implemented that new column using SQL functions rather than specifying a new user defined function. So that's a difference. So if performance matters, then UDFs actually are better to be avoided, and native Spark SQL functions to be used. So that's actually important. Now let's go to the next part, which is performance and optimization. Okay, so we know that in our previous video explaining lazy versus eager evaluation, we mentioned that PySpark is actually does evaluation using lazy approach by default. So PySpark having a better performance and optimization compared to pandas. So what happens is, actually using the explain function, we can actually see its logical plan. So when I gave df.explain of true, in this case, if I actually run this, there is a plan shown, but it doesn't have anything specific because we are not doing any kind of transformations here. So if you look at the plan, it actually calls different columns like category, region, etc. But at the same time, when I actually mention that we are going to create a new data frame optimized, where it is df.select and then region and then sales, and let's filter where the column of sales is greater than 300 or 200. Now in this, we're actually trying to do something. So do some kind of like a filtering here. So it's kind of like an additional operation on the data frame. So now let's see optimized explain, and here you'll be able to see that first actually it will filter all columns, or sorry, all the data from the data set where the sales value is greater than 200, and then it will select the region and sales. So that is going to be the plan. So that's actually the difference when you see here, if you're actually performing more operations, let's say like it can be multiple operations, what the benefit with the PySpark is actually it will first do this optimization, or it will actually create a plan that is actually going to be optimized, and then it will execute it. So it's always going to have a better performance when it does like this. Okay, so that was about performance and optimization, which we already discussed in lazy versus eager approach video also. Okay, so the next thing that we're going to do is writing data. This is also something we already we came across multiple times when we were doing other videos using PySpark, but I just wanted to show you here because this is also an important part of data transformations, because when you do the transformation, after that it's actually important, or it's better if you do the if you save that data in another let's say like a table or Parquet file, etc. So a clean version of the source data after the transformation, so that it's easier to use. So how to do that in our case, because we are using a free edition of Databricks, what I'm going to do is I'm going to actually save it in delta table mode. So df.write.format delta, and the mode is going to be override, and the option will be merge schema, where it's going to be true, and then we will save as table. We will save it under default.transformed data. Okay, so it ran without any errors, and to check whether it really created the table or not, we need to go to catalog and refresh, and under workspace, under default, yes, here you'll be able to see that there is already a table saved with all the columns and the data that we have in our data frame. Okay, so that was about writing data. And the next or the last topic is actually to give a summary of what we discussed so far. So I'm just gonna, because I already have a table created with me, I'm just going to copy paste it, so that rather than writing the whole table again. So here, if you look at the summary, we have a table now with different concepts that we already discussed, which are actually I would say the basic things or the basic concepts when it comes to data transformation, and what kind of method can be used in PySpark. And because SQL is very it's actually like quite familiar with most of the people, so I have tried to have an SQL equivalent so that it can be related. Okay, I think there is no need to actually go through each of them because we already went through in detail. Column selection, select, conditional is actually when, filter, and then aggregation, group by, aggregate, join we already saw. Then window was window, spec we specify using partition by, and then over, using over we can do it. We can actually like use different functions and window functions. Then for pivoting, pivot, and then null handling, drop or fill, and then sort can be done by order by. Then we saw UDF or user defined functions, optimization using cache, and explain. So yeah, SQL equivalent, I think it's not it's actually like quite self-explanatory. So I think that's it about the second part of PySpark data transformations. So these are actually, if you go through this workbook or notebook, actually you will be able to see that we have covered I would say like 70 to 80% of data transformations in real life or real situation, real use cases. And it can be actually like used to transform data. These all different functions can be used to transform data. So we'll be coming up with more videos, trying to do more projects using PySpark, and then we will go through the PySpark data transformation. It may not be necessary to do all of these transformation steps while doing the real life or real project in real use cases, but of course I think these actually like some of these I would say like most probably used while transforming a real data set. So I hope you'll find this session useful, and please let me know your feedback and comments. So thank you, thanks for watching.